All right, everyone. Welcome back for another deep dive.
Always a pleasure.
Tonight's going to be pretty special.
How so?
Well, March 28th, 2025. Like, what if we look up and we see this brand new star just blazing in the sky?
Oh, wow.
It would be incredible.
It would.
Something that really hasn't happened in, what, almost 80 years?
80 years.
The last time this particular star did this was back in 1946.
Yeah, that's a pretty rare event.
Pretty rare.
Yeah.
But the cool thing is, this isn't just some, surprise flash in the pan. Scientists have actually been kind of anticipating that this outburst could be coming.
Oh, wow.
So we're diving into the predicted nova of a star called T Coronae Borealis, or T CrB.
Right.
We're going to be pulling from some recent reports from NASA and from astronomical societies who've been sort of tracking all this.
Interesting.
So you're here with us as we try to understand, what this star explosion is all about.
Absolutely.
Why the signs are pointing to now or really soon. And then how you yourself might actually get to see it.
Yeah.
So we're going to try to keep it fascinating, but not too overwhelming. No need to dust off any old astronomy textbooks.
Exactly. We want to make sure that you're intrigued and getting all the details without being bogged down with the jargon.
Yeah, exactly.
It's the astrophysics.
No hardcore astrophysics here.
Yeah.
So let's start with just kind of looking at the star system in the first place.
Right.
The star that we're talking about is T Coronae Borealis, or T CrB.
T CrB.
Now, it's not alone out there. It's part of what's called the binary system, which just means two stars that are locked in orbit around each other.
Cool.
And you can find this system in the constellation Coronae Borealis.
Coronae Borealis.
Which means the northern crown.
Oh.
So if you're looking up into the northern part of the sky,
right,
that's the general vicinity. It's about 3,000 light years away from us.
3,000 light years.
Which sounds like a lot.
Yeah, it's a big number.
But on a galactic scale, that's actually relatively close.
That's true.
The important thing to understand here is the interplay between these two stars.
Okay, the two stars in the system.
Yeah, so imagine a red giant star.
Okay.
These are stars that are nearing the end of their sort of normal lives.
Right.
They've used up the hydrogen fuel in their core.
Okay.
And they start to expand and cool.
So they get big.
And they get really big.
Okay.
And that's what gives them that reddish kind of glow.
I see.
Like a dying ember.
Ah, okay.
The red giant in T CrB is in this phase.
Okay.
And it's shedding some of its outer layers of gas.
It's losing some of its gas.
It's losing some of its gas.
Interesting.
And that's where the second star in the system comes in.
Okay.
Orbiting the red giant is a white dwarf.
A white dwarf.
Now, a white dwarf is what becomes of a star that's similar to our sun after it's also exhausted its nuclear fuel.
So, like, the ember has gone out?
The ember's gone out.
Okay.
And it's incredibly dense and hot, but it's slowly cooling down over, billions of years.
Oh, wow. Over a really, really long time.
So you have this kind of cosmic dance happening.
Okay.
Where the white dwarf is acting like a gravitational vacuum cleaner.
Oh, wow.
And it's pulling material, mostly hydrogen, from the outer atmosphere of the red giant.
It's sucking it up.
It's sucking it all up.
Okay.
So this gradual accumulation of hydrogen on the white dwarf's surface.
Yeah.
That's kind of the key ingredient for this event that we're anticipating.
The big show.
The big show.
Okay.
Now, here's where it gets really interesting.
Okay.
As this hydrogen layer builds up, it's subjected to immense pressure and heat.
Why?
Because of the white dwarf's strong gravity.
Makes sense.
So all that gathered hydrogen on the white dwarf eventually reaches this critical threshold, and then boom, it ignites in a runaway thermonuclear explosion.
Oh, wow.
Right on the surface.
So like a bomb.
Like a massive hydrogen bomb going off.
Oh, wow.
But on a stellar scale.
Like a stellar scale.
So it's fusing atoms together in this uncontrolled chain reaction.
And that's the explosion.
And that's the explosion.
Okay.
Now, it's important to understand that this explosion is a surface phenomenon.
Okay.
It doesn't destroy the white dwarf itself.
Oh, okay. So it's still there.
It's still there.
Okay.
It's more like just this tremendous burst of energy released from its outer layer.
Got it.
So this sudden release of energy results in a huge, rapid increase in the system's brightness.
Ah, okay.
And that's what makes this usually faint star that you would typically need a telescope to see.
Right.
Suddenly become visible from Earth without any equipment.
So I could just see it.
You could just see it.
Oh, wow.
And this type of stellar brightening is what astronomers call a nova.
A nova.
Which literally means new in Latin.
Oh, that makes sense. A new star appears.
New star appears.
Cool.
So the big question, of course, is When might you actually get to see this?
Yeah, when is this going to happen?
Right.
This big show.
So according to NASA's projections, once this nova reaches its peak brightness, you should be able to see it with the naked eye for several days.
Oh, wow.
After that, it should still be visible with binoculars for more than a week as it kind of fades back to its, normal, fainter state.
So I could get binoculars and see it for even longer?
You could totally get binoculars and see it for even longer.
Okay, cool.
And the brightness is expected to be pretty significant.
Like, how bright are we talking?
Reports are suggesting that it could become as bright as the 48th brightest star in the entire night sky.
The 48th brightest star.
In the entire night sky.
That's pretty bright.
So it'll be about as brilliant as Polaris, the North Star.
Oh, wow, I know that one.
Yeah. So that should give you a sense of how noticeable this could actually be.
Yeah, that's really cool.
Now, here's the part that involves a little bit of cosmic uncertainty.
Okay.
The timing.
Right.
You might have seen some earlier reports suggesting that the explosion could happen around April 2024.
Yeah, I think I saw that somewhere. But that obviously didn't happen.
Obviously, it did not happen.
Okay.
Which really shows how hard it is to actually predict these events.
Yeah, space is big.
Space is very big.
And complicated.
And complicated.
Yeah.
But astronomers did observe that T CrB's brightness dipped.
Dipped.
Back in March and April of 2023.
2023.
And this dimming, some people think that that's actually a sign that the system is getting ready for the outburst.
It's like taking a deep breath before.
Like the calm before the storm.
Yeah, okay.
Right.
Interesting.
But the sources that we've been looking at also point to a slightly wider window.
Okay, I would say like a range of dates.
Like a range of dates.
Yeah.
The research notes from the American Astronomical Society, for example, mention some other possible dates like November 10th, 2025.
Okay.
Or even as late as June 25th, 2026.
So it could be a while.
It could be a little while.
Okay.
But that's really important for managing expectations.
Right.
While it might happen like right now,
Yeah.
today, March 28th, 2025, the scientists are acknowledging that it could be a broader time frame.
Okay. So we just have to kind of wait and see.
Yeah, we kind of have to wait and see.
Okay.
And astronomer Frank Marchis from the SETI Institute
The SETI Institute.
and Unistellar has also weighed in.
What'd he say?
He's been saying that, the ongoing observations are showing that T CrB is acting up.
Acting up?
Which means it's probably gearing up for an eruption.
Oh, wow.
But he also says that trying to say exactly when that'll be is really, really hard.
Yeah, that makes sense.
It's kind of like monitoring a volcano.
Oh, like you can see it's active.
You can see it's active.
Yeah.
But knowing exactly when it's going to erupt
is really hard.
Is super hard.
Okay.
So while we're talking about it maybe happening today, it's important to remember that the universe kind of works on its own time.
Yeah, it doesn't care about our calendars.
It does not care about our calendars.
Okay.
So this could still happen later this year or even next year.
So the suspense is killing me.
I know, right?
But the thing is, it's not totally new, right?
No, it's not.
This has happened before.
This star has a history.
Oh, history.
It's done this before.
Oh, wow.
Historical records show that T CrB has had nova explosions several times in the past.
That's so cool.
So we have accounts from 1787,
wow,
1966, and then, of course, 1946.
So like every 80 years or so?
Roughly every 80 years.
Right, okay.
Which puts our anticipation into this broader context.
Yeah.
It really makes you think about what those people back then thought when they saw this new star suddenly pop up.
Yeah, like what did they think it was?
Right, like what was going on?
Totally.
And, studying these recurring novae is really important for astronomers.
Why?
Because it helps them test and refine their models of like stellar physics. And it lets them understand how mass transfer works in these binary star systems.
Okay.
And what causes these thermonuclear ignitions on white dwarfs.
Got it.
So each time they get to see this, it gives them more data to understand these long-term behaviors.
So it's like a natural experiment.
Yeah, it's a natural experiment happening thousands of light years away.
That's awesome.
So just to recap.
Okay.
T Coronae Borealis.
It's
a binary system with a red giant and a white dwarf.
Right.
The red giant is shedding material onto the white dwarf. And that eventually triggers a huge explosion.
A nova.
A nova.
Right.
On the white dwarf surface, which makes it suddenly super bright.
Visible to the naked eye.
So bright, you can see it with your naked eye.
That's amazing.
And this only happens once every 80 years or so.
80 years.
And it's predicted to happen sometime soon. Maybe now, maybe in the next year or so.
Yeah. It's exciting.
It's pretty exciting.
It is.
And it's cool because, it connects us to history.
Yeah.
people saw this back when our grandparents were young.
Right.
And people saw this hundreds of years ago.
It's amazing.
So it makes you wonder what they thought about it.
Right.
And what future generations will think about it.
When they see it again.
When they see it again.
Wow.
That's deep.
It makes you think about, our place in the universe.
Totally.
And how short our lives are compared to these huge repeating events.
Yeah, you really feel small.
It is kind of humbling.
It is.
So here's a thought for you to take with you today.
Okay.
Maybe go outside tonight and look up at the Northern Crown.
The Northern Crown.
There are some stargazing apps and charts that can help you find it.
Cool.
And, whether T Coronae Borealis decides to put on a show tonight or not, just remember that when you're looking up, you're looking at this huge active universe that's full of amazing and... Definitely keep an eye on, astronomy news.
Yeah.
And announcements, because this story of T CrB and its potential nova is definitely something worth following.
I'll be watching for sure.
Me too. Okay.
Well, until next time.
Until next time.
Thanks for joining us for another deep dive.
Thanks, everyone.